Hello and welcome back. When we last left off, we were taking a look at these nice jaws we made for our custom load cell vise. This episode, we're going to continue on with the project and we're going to get these load cells wired into the summing box and get everything working. Let's get into it. Moving ahead, I figured what we'd try is to mount the 240 or the 120 volt inverter that we're going to use for this on a PVC enclosure box, and then we'll mount the PVC enclosure to the anvil of the vise, and we'll take a look at some more of that then here in a bit. So what I've done is, here's where the 120 volt outlet was soldered on. Here's your Euro American 120 volt outlet. Spoiler alert, these things don't have the ground hooked up. That's a shocking surprise. I don't know what it would really ground anyway, so there's no metal parts, so it doesn't really matter. So what we're going to do is we're going to shove these two wires through this hole, and we're going to take advantage of these other three holes in the extremity, and we will bolt this on there. Now, I already hear you, this is flimsy plastic, it'll probably get broken off. Well, we'll find out. So when this goes together, it is kind of keyed. It actually has a reasonably decent fit. Just like so. Everything's flush. This is relatively rigid. Now, could it snap out? Sure. But I don't think I'm really worried about it, honestly. I've said before, I'm not overly hard on things that I make like this. If I was expecting it to be out in the trade, in the field, or something like that, yeah, probably should be more robust. But just for experimental purposes here in the shop, I think this will be just fine. So what we're going to use for this is a 532 Allen screwdriver for the stainless quarter cap screws I have here, and we're going to use a classic old Klein 7/16 nut driver for the nylocks. I figured I'd use nylocks so it won't work loose. If it starts getting loose like this, I'll know to take it apart and tighten it. And I can always drill additional screws in it if I so see fit. So I think this will be a good starting fit point, and if it starts getting loose, we'll do something about it. Or if it breaks, it was a cheap inverter, ho-hum, I don't really care. So let's get this bolted up, and then we'll get the guts back in the inverter and get the wires poked through, and we'll take a look at some of the other wiring that we're going to get into here. Not a lot of wiring in this project. So there we go, we got them through. Get our nylocks started, just like this. I'm not going to tighten this all the way because we'll want to center it up. I know it's not square with the cover this very second, but that's okay. We'll get them snug, and then we'll get it straight and we'll tighten everything. One nice thing with these Allen screwdrivers, and I'll show you then, it's nice and it's also kind of not nice all at the same time, is they have a ball tip on them. I don't know if that's showing up well or not. So it allows you to get on these angles like this. I have decent engagement everywhere there, so it's not too bad. But let's get that somewhat centered, just like that, and we'll just hairy eyeball that somewhat straight like that. Sure, okay, yep, and just like that. And because it's still sort of stained, we should be able to tighten that. And I should be able to slide all of the guts back together without loosening it. We will see. Okay, so there we go. Tightening devices. Now, what we can do is put the guts back in. So, I didn't show taking this apart, but I left 2 of the plugs for the board. One being the fan, one being the LED light, which we're probably never going to use, but we'll leave it in the board. And then, looking at the board, I'm not an aficionado of these things, but it doesn't look like crap. I mean, when you look at these things, you can kind of tell shoddy craftsmanship when you see it. I do see they didn't really spray a lot of, there's not a lot of sealant on the board, so I would suggest that if you use one of these knockoff inverters around moisture, you're probably not going to have a very long-lasting success with them. These buttons are just right on the board, and your USBs also right on the board. That's okay, that works. And you can see your LED, it's actually labeled, and your fan controller. Now this was our 120, AC1 and AC2, they're labeled on the board. And this is actually nice, flexible wire, so that's nice. As is this, also nice and flexible. So that's welcome. Some decent wire is always a nice thing to find inside of stuff like this. So let's get this reoriented the way it needs to be. And that is this way. I'm probably going to block everything off camera-wise like I normally do. So this only goes in one way. The fan and the light are actually the same plug. So if you were to get this backwards, when it gets warm, the light would come on. But it looks like they actually have the polarity wired backwards. Whatever. I don't know. It may or may not do that. And then this is going to just slide. You can see there's a slot for this to slide in, which is kind of nice. And if I could actually get it to go in that, I would be even better off. Here we go. Just like that. And then that should line up with our USB outlets. Just like that. Fan's plugged in. Now we need to put our buttons back. Here's our light button. And you don't want to put the circle in the square hole in this instance. You want to put the circle in the circle hole. Just like that. And we will have the power, which is the square, goes in the square hole. And it looks like the rubber on these, you can't see any of that, is designed to fit over top of the board, which I will show after I get this together. There we go. So you can see the little rubber insert. This one actually goes over that button completely that's on the board. So that's not too bad. Now, the AC, we're just going to jam these through this hole here. It'll be fine. Plastic is not going to damage the conductors one minute bit. So let's get them shoved through. Just like that. And we will pick those up with butt splices on the inside. Now, our battery, as you can see, there's only two connections on the battery, even though they show all 5 here. It's only hooked up with 2. Now this does have low voltage shutdown, which is also why I've designed this that the light faces this way. Once we get this on here, maybe I'll show you. When it gets to low voltage, the indicator light that it turns on with turns red. So that's your low voltage indication, which isn't really bad. I would prefer if it actually turned it off, but I guess I can deal with that because we designed it now that when we're utilizing this, we'll see the light turn red. So it's not exactly what I want, but I think it'll work. And if we're gonna debauch or something to do something like this, I'd rather do it with a knockoff inverter rather than spend the money on a really expensive one. So now I just need to be patient here and get this slid back together. It might go a little bit hard because of being mounted the way it is, but there we go. We got our 120 volt wires out. We got that all snapped together, and honestly, it's not horrific. It's not bad at all. So now we will take, these are actually posi screws, and I have gotten these fellow, whatever you want to call them, wooden handle posi screwdrivers. I kind of like them. They have a nice engagement. Now I went with the wooden handle because I threw them in my Phillips drawer, and they're just easily identifiable that way. Those in the know, posi normally has that style tip, so it does look a little different. But, you know, if you're just grabbing stuff quick, a different style handle, that's quick. So these have nice engagement. It's a nice screwdriver, actually. And we'll use that to put this back together. Now, a nice trick for plastic, run your screw backwards, and I think you just heard it click there. I'll do it one more time. Run it backwards, and then you're in the thread holes that were already cut, and you will have less failures. You will strip out less things in plastic this way. Just take it that it's snug. Get another one. We'll do the same thing. Run it backwards till we hear it. I think this one's not as loud. I can feel it. You don't really hear it. That's okay. And you'll also know if you don't have it right if it kind of turns hard. Like anything, you just get into stuff, you start learning tricks. There we go, there was our little pop. Go the right direction. So if you ever see on the channel, you see me turn something backwards when I'm getting started, that's actually what I'm doing, is I'm feeling for the thread. I do it with machine screws also, because run it backwards and you can actually feel the thread snap in. Then you know you're starting, and you're not risking cross-threading or spinning it because it's cocked a little bit in the hole. There's a few advantages to it. So anyway, so there we go. We got that put back together on here. It's as rigid as, you know, something bolted to a PVC box cover would be. I don't think it's all that bad. Keep that isolated there. I don't think it's going to turn on anyway. So there we go. We got a big old 12 amp hour bugger on there, and it fits just fine. That's not bad at all. So I think this will work out. Like I said, we'll butt splice those onto the feed that we'll use for our load cell summing box. So now, speaking of the load cell summing box, I guess I'll bring that over. Okay, so a few things have happened. We finished up the jaws. We'll go over that then. And we test wired the summing box. Now this mess of cord I actually want to get rid of, so we can determine. We know that this is our 120 volt connection. That's going to have to get to our inverter. That's okay. What we'll do here is we will determine this. Now that doesn't feel the absolute best in there, the posi. So we're going to go to a Phillips. We're going to go to a good old number 2 Phillips. And that feels a little bit better. So we'll determ that. Determ that. Now a trick you can do for yourself when you have a fair number of terminations like this is you can leave the terminations you're using loose, and you can also somehow, some way, you can mark either the fastener or you can mark the label that's on it, that this is a position that you want to label or that you want to get a wire on. Now here, maybe I'll get a small marker and I'll see if I can put the color on there. That way we'll know which ones are which, but we don't really need to deal with that just yet. I see here that we actually did that already. We color coded it. So here's our load cell. Here's our power in. This unit will work on 240, 220, whatever. Some people say one, some people say the other. It's pretty versatile. So I think what we're going to do is, I'm going to just set that here off to the side for now. We're going to get this mess of cord out of here and we'll be back. Okay, so you may see this and say, well, that mess of cord is marginally better. That's because the load cells here, I actually don't want to shorten the wires on them. Sometimes, and I don't think these are the case, but sometimes load cells are designed to have a cable a certain length. So it's almost always better to not cut them down if you don't have to. The cables are designed for the resistance calculation of the load cell itself. So if you start shortening that, you're going to change resistances and whatever, and you can throw off the reading of the load cells. So I'm going to let this go. Purely my choice. I'm sure there may be some people that decide, nope, I'm just going to cut it. I don't care. That's fine. That's when it's your project, you can do it however you see fit. Now, what we're going to do is we're going to mount this box on the anvil. And what that's going to allow us to do is mount this digital readout. I'm going to hold it low, but you'll get the idea of what I'm going for. Is we're going to be able to mount it so that we can read that digital readout and still push the buttons from the front of the vise. So as we're tightening the vise, we should be able to see what the values are of our load cell summing box. So that should work out, hopefully, pretty well. Going to be a little clunky with the box this big, but I think I can live with it. So that all being said, let's take a look at where we got to with the vise. So the vise, you can see we have the load cells mounted to it. I just want to make sure I don't pinch any of these wires when I stand this up. But the load cell's mounted. Unfortunately, I didn't think a whole lot about trying to time the tightening of this, and they got to where they got to. It is what it is. I can live with it. But what we got here is these load cells are both compression and tension. So what we did here is we drilled a hole in the vise jaws and we slotted that hole so we can put in a crimp connector, and then we can turn the vise this way and actually stretch those crimp connectors and see where they fail. So it's just an idea. Whether or not it's something that works out great, I don't know. We'll find out. You got to try to know. So let me struggle this out a little bit and we'll take a look at these jaws. Now my plan here is that we can take the jaws and use it to repeatedly squeeze crimpers, pliers, cutters, and we could test to see which cutter requires the most force or the least amount of force to do a job. So here's what we're working with. If you look here, I've kind of made like a pliers handle shape in the vise jaw. Here's that slot I was talking about for the crimp connector. We'll turn this over and look at the other jaw. And we have basically mating on this side, the same thing. So hopefully we'll be able to have in here a pliers handle and we can squeeze it, and or we can also take these out, put a crimp connector in here, and self-destruct our crimp. So that, I think, is the rough-in, the first version of what we're going to have for this project. Can we do it differently? Absolutely. Are we going to for now? Probably not. So this is the way, first iteration. We'll give it a try. If it doesn't work, we'll course correct. So there we go. We have a vise with load cells built in. What I'm going to do is lay out and mount this box, drill and tap the anvil of the vise. We've already modified this vise. It's why I bought the cheapest 6-inch vise I could find. I'm not worried about cutting into it. I'm not worried about drilling into it. I'm not worried about tapping it or modifying it in any way for this experiment. I bought the vise knowing that I'd possibly end up butchering it and not having something that I can use for other things. We could always make other jaws for this if we wanted to. So anyway, we're going to drill and tap and mount this on here. And we're also going to cut a slot in here with our Power Plus adapted jigsaw and mount this bad boy right there. And then we will probably do a little bit of wiring, a whiff of wiring, because there is really not a whole lot to this. I think what I'm going to do for wiring, and I haven't 100% decided yet, I think I'm just going to put a disconnect switch here, and later I may cut in a 120 volt feed. But for now, I really like the idea of having this thing run on M18, because my current situation in this shop that I'm in, extension cords all over the place get to just completely out of hand. And this thing has very little draw. The inverter itself running is probably going to draw more than the actual summing box. So we should be able to run a really long time on a small battery, and it should be just fine. So an instrument running off of M12 is just kind of cool. So let's get into this just a little bit more, and I guess I will bring you back maybe when we're cutting this hole with the Power Plus jigsaw. Okay, so what we're starting to do here is when I cut out boxes, I like to hole saw a corner and hole saw the diagonal corner, and then basically you just start cutting up the lines. So I already have this back cut clean through. What I did here on the side is I left just a little piece right here, and then when I cut this side I left just a little piece again. And what that's going to do is hold our slug in so that as we're cutting across here we don't rip up our workpiece. So what we're going to try and do is cut along this line, and we will then clean up our corners. So let's give this a go. We of course have our M18 adapted Power Plus jigsaw. This thing has been great. If you missed the video on this, it's a good saw. Alright, here we go. Okay, so we've got that cut across. Now what we're going to do is make this cut, clean this up. And I'm going to have to take the camera away, but we'll make this other cut and we'll be clear. Alright, looking at it from the other perspective, here we go. And a hole is born. Let's see if it fits. So our piece will go in something like that, and it looks like I have a little bit of trimming to do, which is actually what you always want. So let me get this trimmed a little bit off camera, and we'll come back. I'm always happy when it's tight like that, because then that means we'll have a good tight fit. We can work it into what we need. And I think what we'll do to do that is we're not going to use a saw, because we're going to be taking a partial cut, and that can always, it can sometimes be a mess. So I think what we'll do is we'll try the band file. What the heck, why not? So all I'm going to do is I'm going to take the band file here, and we're going to hold it as vertical as I can, and we'll work across, we'll test fit, we'll work across, we'll test fit. Okay, so we made a little bit of a cut there. Shouldn't say a cut, we sanded a little. So we need a little bit more, not a lot. And we need a little bit out of those sides. So I'm going to hit the top here now. When you do this, it's always better to work into size rather than to be regretful later that you've gone too big. So we're just going to keep working this in, and to have some patience. So now, okay, so you can see our side to side is probably pretty good. Now we just have to work on our top and our bottom. Let's do it. And yes, I'm using the top of the band file, which you're really not supposed to do, but here we are. So there we go. Just a little bit of band filing, and we got ourselves a nicely mounted box. So now we can finish up mounting this in here. We'll get our load cell wiring into here, get it wired up, and assemble everything. Okay, so we can see we've got our box mounted. We've got our summing box rewired. We do not have this wired in yet to the inverter, but first things first. So this is kind of loosely planned to hopefully get in here, and then we can get everything together. It looks like I'm going to have to loosen the screws to get this in, and that's okay. I knew I'd have a tight fit, so be it. But here's our summing wires, or our load cell wires. I just drilled a hole, and that was just big enough, and I wrapped a bunch of electrical tape on both sides. That plastic box will act like a natural grommet. It'll be fine. Alright, so we've got, let's get some of this out of the way. We've got our summing box in. I just had to loosen these up, pull it up. I didn't realize the camera battery died. So we got that in, ready to go. Now what we can do is we can try and get this set. And I'm not quite sure how these work, but we're going to find out right now. So it appears as though we go like this. Goes in, and then we just slide these forward, something like that. And now you'll see what I did on this side. So there's a little, no, you won't see what I did. There's a little tab that we got to get this thing into. Hang on. wait while I fiddle around off camera, because that's obviously going to be helpful. Okay. I think I got one of these not set quite right. Yep, there we go. That's better. So that can go tight in there. That can go tight in there. That's holding our summing box in, so I could probably show you on this one. So they're just a little tab right here that catches, and you just push this up and it holds. You just slide them up, crush this thing as best you can, and that holds in our summing box. So now we are down to 2 connections, and I'm going to get some butt splices and some heat shrink, and we're going to splice this onto there, something like that, and we'll fire this bad boy up and see how it works. In theory it should work. We'll find out. So I left this a little long because at some point I may cut a 120 volt outlet or inlet into the back of this instead of using the Milwaukee power source. I don't know, it's up in the air, so it's good to have options. Okay, and we're back. So I've been test driving these snap-on strippers. Not quite sure exactly how I feel on them yet. I've been just playing around with them. I gotta say they do, I mean, for what they were, I thought they'd be a lot cheaper than this. They are actually made pretty well, but we'll see. But here we have a case where we're stripping some stranded wire. It's pretty small. Let's see how they do. I'm gonna guess it's 20 gauge. Might not be 20 gauge. It did pretty good, actually. So these are tinned on the end. So there we go, just like that. Now, I couldn't find my black heat shrink, so blue it is. Put your heat shrink on before you crimp it. That would generally be the best course of action. And then we're going to strip here again. Guess we'll go with the 20. There we go. Go with the 20 again. Now let's just take a look at that. I do kind of like the lock on these. It's just a little slide thing. Kind of nice. And the only problem I would have with it though is if you were to put these in your pocket, you would be pushing the lock up. So if you're working out of your pockets, that might not be the best. But looking at this, it doesn't appear as though we lost a whole lot of strands, if any, so that's a plus. You never want these things cutting into your strands. So I'm using non-insulated crimp connectors, and these you just kind of jam the wires in just like that. And I'm actually using also snap-on crimper, which I've actually come to really like this thing. I used to always swear by my channel lock one, but I've started to use this just to see how I like it, and I kind of like it. So, I mean, I guess I gotta hold my pinky out or something when I do this, but because it's pretty fancy. But anyway, let me push all my wires off the connector and try this again. Get in here. I'm trying not to block the field of view for the camera, and then by doing so I'm blocking the field of view for myself. So here we go. Give it a nice squeeze, give it the clamps, give it the tug. That's not bad. Do the same thing for the other side. Then we'll get the heat shrink on and heat shrink that. Tap off our metal shavings. So here we go. I know I blocked everything, but here we go. I just needed to get it started. And that's not a bad crimp. It squeezes well. You can see the die imprinted very well there. And it cradled the the crimper or the crimp connector very well. So now we're going to slide our heat shrink over top, and I like to try and get about halfway with the heat shrink, just about like that. And we're going to use our cordless heat gun. Now this takes a little longer to heat up, but once you get it warm, it's not bad. I find if you use this attachment, you get a little bit better heat transfer. But when you have thick heat shrink, this heat gun can struggle. Little stuff like this, as I'm hoping you can actually see, normally goes pretty well. And this isn't high quality shrink tubing. This is just your general old cheapy stuff. Since I found the heat shrink that has glue built into it, and that I really like that stuff. But I'm using up some of my old stuff on projects like this because this isn't going to see moisture. I use the stuff with glue in it more for vehicles and things that I know will see moisture. So we got this mostly done now. I think it actually is done. We just got to put these 4 screws in, jam our wires in. Yeah, okay. Put that on there just like that. And we'll do our backwards plastic trick here. I don't know if we gain much because these screws were never all the way down before. They when they make these boxes, they only just start them. But we'll do it all the same. Okay, here we go, moment of truth. I don't think I can get everything in frame at the same time. So we're going to put the battery on the inverter. Just like that. Turn the inverter on. Turn the inverter on. And we got signs of life. Yeah. So let's zero this. I did figure out zeroing this is this button. There we go. And if I tighten the vise, you can see how much force, at least I hope you can see. Let's see if you can see. Yes, you can. You can see. You can see how much force we are applying to the jaws of the vise. So what the theory here is, and that somewhat zeros, we might have to zero it after every use. What the theory here is that we can use this to try and test a whole bunch of things. So there we go. We made a Franken-vise that will tell us how much force is being exerted both squeezing and pulling. So hopefully I can get into a few things with this in the near future. And we'll get some videos out and see this thing in action, maybe do some testing. So I hope this build was somewhat interesting, a little bit of a hodgepodgey type thing, but that's what messing around in the home shop is all about. You have an idea, you build something, try out your idea, and you find out if it works or not. If it doesn't work, well, you go back to it and try again. But I think I'm going to like this. Let's see here. if I can get everything somewhat in frame, we could at least show there's our inverter on top there, and then side profile. Maybe I can get most of it in there. Just like that. So we got our inverter, have our summing box, and we have our vise with the load cells and our custom jaws that are set up to both squeeze and pull. So stay tuned, and I'm hoping to have another video out not too long. I know it's been a while since we uploaded, but things have just been kind of crazy. So hopefully this is a good splashback into making videos, and we can start using this thing to test stuff. And let us know what you want to have tested. I'm thinking of things like pliers. We could test how much force this, you need to squeeze to cut. Same thing with crimpers. We can look up the average person's hand squeeze, and I'd really like to test the two different styles of crimpers. That's something I'd like to do, because there's two styles, dies like this and dies inverted, and just a bunch of stuff we could try out. So yeah, got an interesting thingamabob here to try and play around with stuff. Let's see what we can do with it. As always, thanks for watching, and have a great day.